Hey mate, here is another practice question for crashing. Looking on the summary sheet that I sent through, there are two different types of questions that you'll normally get. So the difference is, does each activity cost the same amount to crash, which is this example, or does crashing different activities cost different amounts of money? And that's the one we were struggling with tonight. So we'll do one of those afterwards. So for this one, firstly, you have to find the minimum completion time in part A, and then they give you some activities, and they say that they can be reduced by up to 2 weeks, and every one of those reductions or crashes costs $1,000 per week to crash. So these questions are a bit easier because it doesn't matter which order you crash things in, but we'll normally work from left to right to make it easier. And then we have to work out what's the minimum completion time, and then what's the cost to get to that completion time. So the method we used tonight basically gets us through. There's just a couple of details to add. Firstly, write down all the paths. You know how to do those quite well. Then we'll work out the initial completion times. So for AEG, that's 15. And we're working in weeks here. ACDFG is 7, 13, 16, 21. ACDHI is 20. BDFG is 22. And BDHI is 21. And then, like always, we'll star our critical path. So we know that BDFG is our critical path to begin with. And then, when you're doing these crashing questions, we'll do exactly what we did tonight. So let's crash every activity by its maximum, and then that's going to tell us the best or the shortest possible time we can have after crashing. So the new minimum completion time, in other words. New minimum completion time. So let's put up here as our shortest possible time. Alright, so we can crash. Let's look at the first path. Out of A, E, and G, we can crash A, and we can crash E, but we can't crash D. So we can reduce this path by 2 weeks for the A, and another 2 weeks for the G. So the shortest possible time for this one is reduced by 4, so it's only 11 weeks. The next one, we can crash A, D, and F. So 2, 4, and 6. So this can be reduced to 15 weeks. The next one, we can reduce A, D, but that's all. So we can reduce by 2 and 4 down to 16 weeks. We can crash B, D, and F in this one, so that goes down to 16 weeks as well. And then we can reduce B and D in the last one, which is 2, 4 weeks, so this can go down to 17. So 17 is the best we can do, and that's our new minimum completion time that we're aiming to get to. It's good to highlight that as well because that's the goal that we're aiming for. So as we're working step by step, as soon as any of these paths gets to 17, then we know that we're finished and we don't have to go any lower than that, because that's going to cost more money because it costs $1,000 per week. So the whole point of these questions is to keep crashing until we get to 17 weeks, but no further, because that's going to cost $1,000 per week. And the whole point of these project management questions is to save money, as well as saving time. Okay, so we've got to here. We know crashing each activity costs $1,000 per week, so we're going to go step by step, and we're always going to reduce the path that's the critical path currently. So at the very beginning, this is the critical path, and it doesn't matter which activity we choose to crash, as long as it's one of the ones that we're allowed to crash: A, B, D, E, F. So the best method is to just work from left to right. So let's choose B to crash by 1. So we'll reduce B by 1. And you know the method from here. So we're looking through any of these paths. To any of these paths have the B activity, and they're going to reduce by 1, but the first 3 will not. So the first one's still 15, because we're working back at the initial values. The second one's still 21. Third one's still 20, but then these two reduce by 1. 21 and 20. Okay, so we have 2 new critical paths. So then we're looking to reduce both of these paths at the same time if possible. So let's look through. They don't both have an A. They don't both have a B or a C, but they do both have a D. So let's reduce D next, because that's going to reduce both the critical paths. Okay, so the first one's still 15, but that doesn't matter because it's already less than 17, which is our goal. So really, we don't even care about the first path. The second one has a D, so that goes down to 20. The next one has a D, that goes down to 19. The next one and all the rest have a D, so they all go down 20 and 19, and our critical paths are still those 2. So since we're allowed to reduce activities by up to 2 weeks, let's just do D again, because we know it's going to reduce the 2 critical paths at the moment. So reduce D again. The first path is still 15, and all the others go down by 1. 19, 18, 19, and 18. Okay, those 2 are still the critical path. So how else can we now reduce those 2 together? A, B, and C, we already know we can't do. Because they both don't have them. D, we've already reduced twice. They both have an F, and yes, we can reduce F. So we definitely want to crash F next, because it's going to get reduce both paths for only $1,000. Okay, the first one doesn't have an F, still 15. Yes, this goes down to 18. The next one, no, so that's still 18. The next one, yes, 18. And then the last one, no. Okay, now we've got 4 new critical paths. So it would be great if there was one activity that all of these paths had. Well, they all have Ds, but we've already crashed D twice. So let's just work on... well, from here, the best way to work is on the activity that we're trying to get to, because we know this last path, that's going to be the final critical path. So let's aim to get this one down to 17 first. And as always, working from left to right is the best way to do it. And it's got a B. We've only crashed B once, and we can crash B twice. So we're going to do B for a second time, because we know that's going to get this last path down to 17. Okay, the first one, still 15. The second one, still 18. Still 18. And then the last 2 go down to 17. So now we've hit our goal. So you can basically, I like to circle them and say, all right, we've reached the goal. And now we know we don't need to affect or reduce these last two jobs. Otherwise it's going to cost excess money that we don't need to pay. So all we need to do is get these last two critical paths down by 1. So we're thinking, okay, is there one activity that we can do that we can crash that's going to reduce both of these second and third paths? And always work from left to right. A, we haven't crashed yet, so we can crash A. So let's do that to finish. To crash A, the first one does have an A in it, not that it matters. And then the last two go down to 17, and the final two stay at 17. And so our last two activities, they've both hit 17, which is our goal minimum completion time. And once every path has hit the 17, and the original one hit the 17 at the very beginning, then that's as much money as we need to spend. There's no point spending any more money because we can't improve this path anymore. And if we go back and check, that makes sense because we've already crashed B twice, 1, 2, and we've already crashed D twice, 1, 2, and H and I, they're not any activity that we can reduce or crash anymore. So that's it. So the new minimum completion time is 17 weeks, and we crashed B, D, D, F, B, and A. And since they cost $1,000 per week, that's 1, 2, 3, 4, 5, 6, $6,000. Okay, that's how you do the problems when all of the crashing costs the same.